Okay, let's do a net ionic equation problem. So give the net ionic equation for the reaction, if any, that occurs when aqueous solutions of potassium sulfide and iron nitrate are mixed. Okay, so let's go ahead and let's write down the reaction here. I have, these are aqueous, so I have K2S, and that's aqueous, plus I have iron nitrate, it's iron 2 nitrate, and then what is that going to produce, if any? Well, let's go ahead and do the reaction. Again, this is going to be a double displacement here. These two people came to the dance together, the potassium and the sulfide, and the iron and the nitrate came together, and they're going to split up. So this potassium is going to then hook up with the nitrate, and the iron is going to be with the sulfide, the iron 2. And so my products are going to be KNO3 plus iron Fe, iron 2 sulfide. So these are my products. Now, the next thing we have to do is determine whether these are going to be soluble or insoluble, since this is being done in solution. There is no gas evolution coming off here. And so let's figure out what it's going to be. Let's look at my solubility table here. So let's look at the potassium and then the iron sulfide. So potassium, everything with a potassium in it is soluble. Okay, so that potassium nitrate is going to be soluble. The sulfide is what we're going to be looking at next. Now, sulfides are almost always insoluble unless it pairs with calcium, strontium, barium. Okay, those are going to be soluble, as is going to be lithium, sodium, potassium, and ammonium. Well, we have iron, it's not here, so that one is actually going to be a solid. That is going to be what is forming our precipitate. So let's go back here, and so this is going to be a aqueous solution, and this is going to be our solid. Now let's make sure we balance this real quick. And so I have 2 potassium, so I'm going to put a 2 right there. And then I think that's does it for us. Okay, so now I have to write the net ionic equation. Anything that has aqueous by it is going to be what I'm going to split up. If it has a solid, if it's a gas, if it's a liquid, I am not going to split those up into the ions. Only if it has aqueous should you ever be splitting that up into its individual ions. And so here I have 2K plus S minus 2 plus Fe plus that 2 is going to come up in front. That's a Fe plus 2 plus 2NO3 minus, and that is going to give me 2K plus, I split that up because it says aqueous, plus 2NO3 minus plus FeS, and that is going to be my solid. This is going to be the complete ionic equation, and I'll have you do a complete ionic equation. So let's come up to the net ionic equation, and we can cross out on both sides of the equation those ions aren't doing anything. So the 2K pluses are going to cancel out. The 2NO3 minuses are going to cancel each other out, and that leaves me with an S minus 2 plus Fe plus 2, and that is going to give me my iron sulfide, my solid. This is going to be the net ionic equation for me as a teacher. I guess I don't care if you put the aqueous down here. We already know it's aqueous by how we wrote it up here. And we also know it was aqueous because we split those up. Nonetheless, this is how I would write the net ionic equation when these two things react.